So here we go again, classifying matter. We learned earlier that pure substances, we're not talking about mixtures now, but pure substances, can be either elements or compounds. Elements can be divided into two categories: atomic, where the individual pieces are individual atoms, or molecular, where you actually have molecules made from two or more atoms of the same element. For compounds, we can have molecular compounds with covalent bonds, or we can have ionic compounds with ionic bonds. Most elements exist as atomic elements. They just have individual atoms as their basic units. Some elements exist as molecules, and there are 7 of those that you do need to remember. 7 diatomic elements. So these guys right here. They exist as 2 atoms of that element covalently bonded together. We'll learn later why they do that. For now, we just have to remember that these guys do that. So chlorine is one of those. In chlorine gas, there are not individual chlorine atoms floating around. There are chlorine molecules. They are diatomic because it's 2 atoms. So the formulas for these elements are the element symbol with a 2 following. There are 2 common polyatomic elements, P4 and S8. You should know that exists and not be surprised if you see it, but I'm not going to require that you memorize those. So here are molecular elements shown on the periodic table. So there's phosphorus and sulfur, and selenium also forms a polyatomic molecule. Those are nice, but we're interested in the yellow ones. I think it's interesting that if you start at element 7 and you make a 7, those are 6 of the 7 diatomic elements, and then over here's hydrogen. Hydrogen seems to want to be an exception to all the rules. It's just not going along with the group. So here we've got all of these guys behaving very nicely, and then there's hydrogen. Another way to remember which ones are diatomic is a mnemonic, which is a sentence that's kind of silly, but the first letters represent something you need to remember. So horses need oats for clear brown eyes. This is really great until we get to the eyes part. So H, hydrogen, nitrogen, oxygen, fluorine, Cl for chlorine, Br for bromine, iodine. We need to know these because when these show up in a chemical equation and we need to write their formula, we have to put the 2 there. And we need to know when to do that and when not to. Any questions? So those are elements. Compounds, molecular compounds, we just talked about covalent bonds, so we've got 2 or more nonmetals bound together because they're sharing electrons. So molecules are composed of atoms. The molecules are the basic units of molecular compounds. So here we have an illustration of propane. And so each of these molecules is the base unit of propane. It's got 3 carbons and 8 hydrogens. They're all the same. Dry ice is a compound composed of CO2 molecules. Water is composed of H2O molecules. Then we have ionic compounds. Ionic compounds form between metals and nonmetals. There are ionic compounds that do not contain metals. Those are very unusual in this class, at least. We do lie to you in general chemistry sometimes, because if we told you the whole truth, it would just take way too long, okay? So, ionic compounds, metals and nonmetals, mostly. I have a hard time lying. I always qualify things. Okay, so in an ionic compound, the basic unit is a formula unit. There are no molecules, right? So here's a representation of sodium chloride. You've got the chlorine ions and the sodium ions, and they just go every other one. However big the sodium chloride crystal is, it's just alternating sodium ions and chlorine ions. And so unlike a molecule, let's go back to this one, unlike a molecule where we have individual units that have this specific ratio of atoms, in an ionic compound, we don't have that. We just have the overall ratio. So the formula is given as the lowest ratio of cation to anion. So ionic compound formulas are empirical formulas because there are no molecules in an ionic compound. I'll give you a clue. There's a lab coming up in the future where we're actually going to determine the empirical formula of a compound, and there's a post-lab question that asks about empirical formulas and molecular formulas for ionic compounds. And I'm talking right now about the answer to that question. You can't have a molecular formula for an ionic compound because there aren't any molecules. If you insist on thinking of a molecule, the entire crystal would be one molecule, and every crystal would have a different number of atoms in it, right? The ratio for all of them would be 1-to-1. Sodium chloride, there's always one sodium ion for every chloride ion. But in this crystal of salt and that crystal of salt, there are not the same number of atoms. There's the same ratio. And so there's no point in trying to figure out how many atoms are in this one particular piece of sodium chloride. Does that make sense? Does anybody have any questions? And if you think that the Morton Salt Company goes to great lengths to make your salt in little square crystals, that's not true. Salt naturally does that. It just kind of happens. So ions. Polyatomic ions. So I gave you a list of these to memorize. A polyatomic ion is an ion that is itself composed of covalently bonded atoms. What makes it different from a molecule is that a polyatomic ion overall is either missing one or more electrons, or it has one or more extra electrons, and so it has a charge. So the difference between a polyatomic ion and a molecule is that an ion has a charge. And so many common ionic compounds have these polyatomic ions in them. So here's a couple of examples. NaNO3. In this class, ionic compounds will always just have two types of ions, one type of cation and one type of anion. And so we have to break this into two pieces. One is going to be the sodium, and then everything else is the other ion, and hopefully you recognize that as the nitrate ion. This is CaCO3. It's got a calcium ion in it, and this CO3 carbonate ion. The carbonate ion is composed of a carbon atom, 3 oxygen atoms covalently bonded together with a couple of extra electrons thrown on top. And we'll talk a lot more about these later. Any questions for now? Let's practice classifying substances. Are these an atomic element, a molecular compound, or an ionic compound? So the first one, fluorine. Is it an element or a compound, first of all? It's an element. Is it a molecular element or an atomic element? It's molecular. So Me for molecular element. So fluorine on the periodic table is over there, number 9. It's in the corner of that 7, or it's the 4 in Horses Need Oats, 4 clear brown eyes. You just have to remember that. Okay, N2O, is this an element or a compound? It's a compound. The big clue there is 2 capital letters. That means there's 2 different elements. It's a compound. Then we have to identify molecular or ionic. Molecular would be 2 nonmetals, and ionic would be a metal and a nonmetal. So we learn to identify from position on the periodic table whether elements are metals or nonmetals. So if you find nitrogen and oxygen on here, they are both what? Nonmetals. So if they're nonmetals, nobody wants to form a positive ion, so they're going to be a molecular compound. Okay? Silver, element or compound? Element. Here's a tip on the element versus compound if you're looking at names. Most compounds have 2 words, sometimes 3 in their names. There are exceptions like water, some of the common names, but most compounds have more than 1 word. So if you see a single word like this, and it's something you can find on the periodic table, then it's an element. Silver, is that molecular or atomic? It's going to be atomic. It's not one of the 7. And I won't try to trick you by asking you about sulfur or selenium or phosphorus. K2O, element or compound? Compound. Ionic or molecular? Ionic.
How do you know if it's ionic or?
We know this is ionic because the first element, potassium, is a metal. Oxygen is a nonmetal. So if we have a metal and a nonmetal, it's ionic. Here we've got 2 nonmetals. And the last one, what's this? Ionic compound. So a compound because we have 2 different capital letters here. Ionic because iron is a metal, oxygen is a nonmetal. Any questions?